Large language models are brilliant, but their internal memory is static, outdated, and prone to hallucinations. Retrieval Augmented Generation, or RAG, transforms an LLM from a student taking a closed-book test into an expert researcher with an open-book library. Instead of memorizing everything, the model retrieves exact source facts in real time before answering. Production RAG begins with data ingestion. Never just dump whole documents. As Greg Kamrat demonstrated, you must split text intelligently using semantic chunking and markdown structure. Each chunk is passed to an embedding model like text, embedding, 3 or BGEM3, creating a high-dimensional vector representation of its meaning. Naive vector search fails when users search for exact product IDs or acronyms. The gold standard used in industry is hybrid search, combining BM25 keyword matching with dense vector cosine similarity via reciprocal rank fusion. Then, a cross-encoder reranker scores the top 50 passages to deliver the ultimate top 5 to the context window. In advanced architectures, we implement Agentic RAG. If a user asks an ambiguous question, the system uses hypothetical document embeddings or multi-query decomposition to rewrite the search. The agent critiques its own retrieved context, fetches missing details if needed, and verifies the final answer against ground truth facts. To graduate from prototype to production, evaluate your system using the RAG's metric triad: faithfulness, answer relevance, and context precision. Pair this with vector database caching and automated tracing to build a scalable, enterprise-grade AI engine.